So hello everyone, welcome to my another video. In today's video I'll be taking the recent Codenation Hiring Challenge, the 26 Gen Hiring Challenge 2021 problem second. So you can find all the problem statements of that hiring challenge on this Code Forces blog. I'll be sharing the link in the description, and I'll be taking the second problem, which is bit queries. So here's the problem. You can read the problem and try out if you want once and come back to get the solution. So I'll basically explain you the question. So the question states that there is an array of n integers, and one operation defines is you can increment any element from that array. This is the definition of the operation. You will be given q queries. In each query you are given two integers l and r, which defines a range from l to r. So you have to output number of operations required to make at least one pair in that range L to R whose bitwise AND is strictly greater than 0. See this, there is at least one pair. So you have to output number of operations for each query you require to make at least one pair whose bitwise AND is strictly greater than 0. And another thing is each query is independent. That is, for each query consider the given array A to answer it. Means the array you change for the query first would not affect the array for second query. So here is the constraints given. The n and q would be less than equals to 10 to the power 5 and greater than 2, and the ai, each element would be from 10 to the power 9, and this means that the range will at least be at the difference of 1. Means l and r, the difference between them would at least be 1, means 1 or 2 or 3 at least, or can be greater. So this was the question. So let me take an array. So this is my array and their indices. It is 0 indexed array, so 0 1 2 3 4 5 6 7, these are the indexes. And the thing is, the range queries will be from 0 index, means it could be 0 to 2, 0 to 3, 1 to 3, like that. If you work with bits, there could be, if the number is 10 to the power 9, there could be 32 bits at max. So if you pre-compute something, and for each element to answer the queries in limited time, like let's say log n or O of 1, then this is possible to answer each query without getting time limit exceeded. So you have to do some pre-computation for that. So first of all, let's denote each number in its binary notation. So it is 0 1 1 0 1 1. So here it's binary notation of each number. So what is the first observation here? That for getting bitwise AND greater than 0 in a pair, there should be at least one bit set in both of them, common bit set. Let's say the second bit here and here both are set, so the bitwise AND of both of them would be greater than 0. But in the first and second, there are no common bit set. It's the first bit here is 0 and 1, the second bit here is 1 and here is 0, so the bitwise AND will be 0. So you need to have at least one common bit set in two numbers to have their bitwise AND greater than 0. So we have to do some pre-computation here so that we can answer queries very faster. So what kind of pre-computation we can use here? We will make an array, and for each element we will store the closest pair who has at least one bit set. Means for 4, the closest pair who has at least one bit set is 2 and 3, right? For 3 itself, the closest pair is 2 and 3 including itself. the second bit is set in both of them. So for 5 it is 4 and 5, because this is 1 and this is also 1, so you can include itself. For 16 you can say the closest pair whose at least one bit is set, common bit is set, is 5 and 6. So this is the bit. It's not necessary that they should be consecutive. It can be like if this is 8 and this is 6. So this will be the pair 5 and 6 again. So we have to store the furthest number of that pair, the index of that number of that pair, the closest pair's furthest index. So here we will for 16 we will store 4, and let me change back it, 6 and 8. For 6 the closest pair is they itself, 5 and 6, because they have the third bit set and which is both of them is common. So the furthest of that pair is 4 in fourth index, so we will store 4. For 8 also it is 4, because the closest pair is 5 and 6 again, and their furthest index is 4. For 5 it is 3, because the third of both of them are commonly set, and it is the closest pair, so it is 3. For 4 you can see for 4 it is the closest pair is 2, 3, so the furthest index for that pair is 1, so we will store 1. Say similar for 3, which is 1, 2 and 3 is the closest pair and the furthest index is 1. And finally for 2, the closest pair, there is no closest pair to its left, so -1, and similar for 1, no closest pair to its left, so -1. So here is our array, which is closest set bit array. I can call it CSB for short form. So this will contain these values, and we can answer each query in O of 1 time by this value itself. We can at least say that is there any operation required or not, and if there any operation required, we will calculate it in further steps, and I will tell you how to do that later. But first of all, we have to at least know that is there any pair already, or we have to do some operation to make that pair. So this will tell us if there is a pair or not. So how does this will tell us is there any pair in that range or not. So let's say we got a pair, L equals to 0 and R equals to 3, means this pair, means this pair 0 to 3. So we'll check for the rightmost element of that range, which is the third index, the closest, what is the closest set bit, which is 1. So is the 1 first index is coming inside the range, is it, means is the first index coming in between 0 to 3? Yeah, it is, because 1 lies in between them. So in between 0 to 3 there is at least one pair whose bitwise end is greater than 0. So we don't have to do any operation, so the answer for that query is 0. Let's say our range is 0 to 2, L equals to 0 and R equals to 2. So for the range equals to 2, we will check what is the closest set bit of 2, which is 1. Is 1 lie between this range 0 to 2? Yeah, it lies 0 to 1, 2. So yeah, there is again a pair which is 2, 3, which has bitwise and greater than 0. Finally we have a range, let's say 6 to 7. Then for 7, L equals to 6 and R equals to 7. So for 7, the closest set bit is 4. CSB of 7 is 4. Does 4 lie between 6 to 7? No. So means the closest set pair for 7 is somewhere here, the 4th index. So we can say that we have to do some operations in this range to make a pair whose bitwise end is greater than 0. So the answer here is not 0 but something other than 0. Means we have to do some operations to make that happen. So how to calculate this closest set bit array? So we know that the constraints given is, let's say for the constraint given is each element will be less than or equal to 10 power 9, means the total number of bits an element can have maximum is 32, means each number could have 32 bits. So what we will do is we will iterate through each bit and find the closest pair for each bit and store the maximum for each bit here. So first of all we will initialize the CSB with -1. For each element we will start and we will iterate this for each bit to form our CSB from left to right. So for first bit you can see that it is 1. So we will have two variables, which is check and another one which is set to 1 initially, and set which is set to -1 again initially. And for each bit we will initially set this -1 and -1. So first of all we will doing for bit 1, the first bit. So is it set? Yes. So if the bit is set in the current element, what we will do is set equals to check and check equals to the index. Index is the current index. Loop. And finally we will CSB of particular index is equals to max CSB of that index. For initial case it will be -1 and set. Note that as the check was -1 initially, so the set will again be check, means the set in this case for the very first bit set is again -1, and later on we will be setting the check to index, means now after the first element our check will become 0, means this index, and set will still be -1, and CSB of index is max of -1, which was initially -1, and set which is also -1. So the CSB of index will be -1 here again. So the first one will be -1, then we will iterate the index. Our index will be here. We will check whether the first bit is set. No. If it is not set, we will directly run this. CSB of index is maximum of CSB index minus and set maximum of both, which is still -1 because the CSB of index initially was -1 and the set wasn't changed, so it is also -1. Now we will iterate to third index, means second index. Is the bit set, means the first bit set. We will do this for each bit actually. from 1 to 32. So is the bit set? Yes, the first bit is set here. So what we have to do is set equals to check. Our check was 0, so set will become 0 and check the current index, which is 2, and again setting the CSB of 2, maximum of CSB of index, which was -1, and set, which became 0 now. So -1 and 0, which will give us CSB of 2 is 0. So now it became 0. To the next. So for the third index, is the bit set? No. So again, not running this loop, directly doing this, -1 and 0 give us 0. Is the first bit set for the fourth index? Yes. Sorry, fourth index, we are at here. So we will run this, the bit is set. So we will set it to the check. Our check was 2, so set will become 2 now, and check will become index, the current index, which is 4. -1 and set will become 2, so CSB of 4 will become 2, so 2 here. Similarly, we will do this for remaining indexes, and you can see as from here there is no, the first bit is not set in any of them, so all of them will become 2, 2 and 2. Now the bit 1 is over. We will similarly go for bit 2 and again initialize it with -1 and -1. Likewise, we will iterate to each index 32 times for 32 bits, and we will update the CSB to get the closest pair who has at least one common bit set. So after the updation of 32 bits, the array will look like this: -1, -1, 1, 1, 3, 4, 4, 4, and this will definitely tell us whether we have to do any operation or we don't have to do any operation. Now the simple part is remaining. Let's say we got a range whose CSB was out of that range, means we have to do at least one operation to make at least one pair's bitwise AND greater than 0. So how we will do that? So it is very simple. So again we have to make one array which will be odd prefix array. Another observation is, if in the range there is at least one odd number, let's say 1, 3 or 5, at least one odd number, then we only have to add +1, means we have to add +1 to any even number in that range, say 2 + 1, which will become 3. So there is at least one odd number, and now we make another even number also odd. If there are, then the range will have two odd numbers now, so it will definitely have a bitwise AND greater than 0, because bitwise AND of any two odd numbers will never be 0. If there is at least one odd number, we have to make one more odd number in that range, and if there are no odd number present in that range, then we have to make two even numbers odd. So we have to plus 2, because to make one odd even number odd we will do +1, and another even number odd we will do +1. So there would be two operations. So this is the second observation, which is, if there is at least one odd number present, then we have to do +1 operation, and if there is no odd number present, then we have to do two operations. So how to find this thing, that whether there is at least one odd number present in that range or not? So it is also quite simple. It is very simple than the previous one. Let's say our array is 1, 2, 3, 4, 5, 6, 7, 8. From starting from left to right, odd of prev I equals to 1 plus odd of prev I minus 1 if the current number, if the ith number is odd, or odd previous of I minus 1 if the ith is even. So this is the basic formula for creating our odd pre array, and by that we can definitely easily find out whether the range L to R has at least one odd number or not. If there is not a single odd number, then the output will be 2, because then they all are even numbers and we have to do two operations to make two even numbers odd. You can check out the code. So this is my array containing n integers, and I am creating a closest set bit array, initializing it with -1. Now I am iterating for each bit 0 to 32 and initializing check index and set index to -1, as I said. Now for each number, if the bit is set, the current bit is set, I am doing set index equals to check index and check index equals to I, and finally the closest set bit I equals to max of closest set bit I and the set index. So this will make my closest set bit. I will do that for all the 32 bits for each index, for each element. So the complexity would be 32 times n, and for answering each query it is O of 1. So this is probably good enough. So for calculating the odd previous array, I am initializing n with 0. Now if I is 0 means there is no previous element present, and if the ith element is odd, then that particular odd previous will be 1, else means there are previous element present, and I am first of all initializing that particular with odd previous I, and if the particular element is also odd, I am just incrementing it by 1. So for each query you can see here, I am taking the L and R, the range from L to R. If closest set bit is present in the range, then no need of any increment, means if closest pair which has common set bit in the range, present in between the range, then the output will be 0. Else if at least one odd number present in the range, if there is at least one odd number present in the range, then we have to increment just one another even number, so that they make their bitwise and greater than 0. Else then there is no closest set bit and no odd number present in that range, means they all are even with no pair sharing the same bit, then we have to increment two numbers by 1 to make them odd. The output can only be 0, 1 and 2. So this was the solution to this problem, and it was actually pretty simple among all other questions in the contest, and I was able to do this one in the contest. I will be sharing this code link in the description. So thanks for watching the video guys, and if you like it, subscribe and like the video and share among your friends who took this contest or even not. Bye.